this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, today we will be looking into domain, range and graph of cot and cot inverse x. And for that, let's have an unit circle where at 0, pi by 2, pi, 3 pi by 2, coordinates are 1, 0, 0, 1, minus 1, 0 and 0, minus 1. Now at 0, cot 0 is cos 0 over sine 0, where cos 0 is 1. So 1 over sine 0 is 0. So 1 over 0, which is not defined. So at 0, this function is not defined. Now at pi, cot pi is cos pi over sine pi, and cos pi is minus 1 and sine pi is 0. So minus 1 over 0, again it is not defined. So at pi, this function is not defined again. So this function will not be defined at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi and so on. So we will have asymptotes at these points. So we will have asymptotes at 0, pi, 2 pi, 3 pi and so on. So let's first draw these asymptotes at 0, pi, 2 pi and on negative side minus pi, minus 2 pi. Now at pi by 2, cot pi by 2 is cos pi by 2 over sine pi by 2, where cos pi by 2 is 0 and sine pi by 2 is 1. So 0 over 1 is 0. Now at 3 pi by 2, cot 3 pi by 2 is cos 3 pi by 2 over sine 3 pi by 2, and cos 3 pi by 2 is 0 and sine 3 pi by 2 is minus 1. So 0 over minus 1 is 0 again. Also, cot is positive in first and third quadrant and it is negative in second and fourth quadrant. So the domain of this function, that is cot x, is any real number x, but x cannot be equal to 0, pi, 2 pi, 3 pi and so on, or we can simply write it as x cannot be n pi, and the range of this function is from minus infinity to plus infinity. So for domain, x can be any real number except n pi. The x cannot be n pi and its range is from minus infinity to plus infinity. Now let's look into the behavior of this function when x is approaching towards 0 or it is approaching towards pi. So from pi by 2, when x is approaching towards 0, then fx or y will be approaching towards plus infinity. And when x is approaching towards pi, then fx or y will be approaching towards minus infinity. So towards 0, y will be towards plus infinity, and towards pi, then y will be towards minus infinity. So at pi by 2, when x will move towards 0, then y will move towards plus pi, and when it will move towards pi, then y will move towards minus infinity. So when x is moving towards 0, then it is moving up towards plus infinity, and when x is moving towards pi, then it is going down towards minus infinity. Now at 3 pi by 2, so at 3 pi by 2, when x is moving towards pi, then fx or y will be moving towards plus infinity. And when x is moving towards 2 pi, then fx or y will be moving towards minus infinity. So when x is moving towards pi, then y will be moving towards plus infinity, and when it is moving towards 2 pi, it is going down towards minus infinity. So similarly, we can graph for other points too. So for the function fx is equals to cot x, domain is x cannot be n pi, and its range is from minus infinity to plus infinity. Now for this function to have an inverse, it must pass horizontal line test. So let's see if it will pass or not. Now since this horizontal line is intersecting this graph at more than one point, so it will fail the test. So this function will not have an inverse until we reduce its domain. So let's reduce it from minus pi by 2 to pi by 2 and see if it will pass the test. And as we can see, this time it will pass the test between this reduced domain. So we can say that reduced domain is from minus pi by 2 to 0, and then from 0 to pi by 2, because 0 is not included, because at 0 we have asymptote and this function is not defined at 0. So now this is one way to find the reduced domain, that is from minus pi by 2 to 0, and then from 0 to pi by 2 where 0 is excluded. Now another reduced domain could be between 0 and pi, because between 0 and pi this function will pass the horizontal line test again. So we can say that this is the principal value branch, where principal value of cot inverse exists within this range. So a second possible reduced domain is from 0 to pi. Now big question is which one is correct. So in my opinion both are correct, like this one is correct too, but the second one is more widely used. So we will be using this reduced domain. So now domain of cot inverse x is range of cot x, that is from minus infinity to plus infinity, and range will be the reduced domain of cot x, and that reduced domain is from 0 to pi. So for function fx is equals to cot inverse x, domain is from minus infinity to plus infinity, that is from minus infinity to plus infinity, and the range is from 0 to pi, that is from 0 to pi, and we will have horizontal asymptote at 0, pi, 2 pi, minus pi, minus 2 pi. Now let's see the behavior of this function at pi by 2, and we know that for inverse function the role of x and y get interchanged. So now when y is moving towards 0, then x will be moving towards plus infinity, and when y will be moving towards pi, then x will be moving towards minus infinity. So when y is moving down towards 0, then x will be moving towards right, towards plus infinity. And when y is moving up towards pi, then x is moving to the left towards minus infinity. Similarly, we can graph for other points too. So the range of cot inverse is from 0 to pi, which is the principal value branch of cot inverse, where all the principal values of cot inverse exist. So this is how we graph cot and cot inverse.